It is a matter of personal emotion to be here, to say a few words, condensing 50 years of my acquaintance with Professor Lee. I was witnessing his development in the late 60s when he started making epoch-making experiments for us chemists. Experiments which were showing that you can really see atoms and molecules. Going back to the debate of Boltzmann and the thermodynamicists of the beginning of the century, finally the technology allowed to see how atoms and molecules do when they encounter, when they see each other, when they decide whether they like it them or not, the way they would orient themselves in order to go on reactive systems. Then the technologies developed on molecules of ever-increasing importance, and now we can say that we have very keen tools to see these events at the microscopic level, to decide then, when we have complex chemical reactions, how we can decompose them in elementary processes, and then seeing eventually we have almost filled up the gap between microscopic and macroscopic world with theory and experiments. So we can go from down up and to up down for many systems of common and general interest. He got his Nobel Prize in 1986, exactly 50 years, well, more than 50 years, 30 years from now, and together with Professor Herschbach, that was the person I went personally to be a postdoc, and we were postdoc together, and they got the Nobel Prize together, and also I'm glad to say that it was exactly the same year that Rita Levi-Montalcini got the Nobel Prize for medicine. And now I cannot go on. He had been visiting us very frequently because he became president of the Accademia Sinica in Taiwan, and then president of the Association of World Academies. Over those years, he was very influential, and is one of the few members of the scientists of the Pontifical Academy that split from the Lincei after Porta Pia, and so he comes every year to meetings with the Pope, and that's also an occasion for me to meet him again. And he's coming back from a visit to Dalai Lama, and from 3 days ago. So science, limitation of science, power of science, how science should do resilience with respect to ignorance, which is one of the themes that our president was focusing on this morning. He's the person that how live together with religion, how to live together with different religions, but essentially continuing our work of battle against ignorance. I think, I don't know, do I have more time? I have to finish, so I thank you very much, and that's it.
Buonasera. Distinguished guests, ladies and gentlemen, it is really my great honor to be elected as a foreign member of Accademia, Nazionale, Lincei. I was born in 1936, and when I entered the elementary school, Second World War is nearly coming to an end. At that time, B-29 from US was bombing Taiwan on a daily basis. School was closed, house was destroyed, and we had a miserable time running into the mountains without attending the school for 2 years. And I said we had a miserable time, but actually that was the most wonderful time in my life. I live in the mountains without having to attend the class and learn everything from Mother Nature, how to live, how the season changes. And so I always encourage students to go to the mountain to live for 2 years rather than sit there and just listen to the lectures. But after the war, things are changing all over the world, like socialist revolution in China, Japanese returned to Japan, and mainland Chinese came to Taiwan. Everything was changing, and so in Europe, you see the independence of Israel, and Palestinian people were suffering, running away. And at that time, actually, when I turn in the pages of popular science, this picture really impressed me. So, can you change my wool to nylon? In spite of the fact we knew how science influencing the human society through the weapons, but by asking scientists to change the wool into nylon is something really fantastic, and that attracted me very much about science. In my home, my parents are both teachers. In the bookshelf, if I don't have time, I always pull the book. It's a Japanese book published in Japan about Leonardo da Vinci, and always look at his art, his machine, science, and enormously impressed. And especially, I have the fascination about machining. And other person who influenced me is Madame Curie. Through her book, I realized how a beautiful life one can enjoy. And I don't want to go into the detail, but what really changed me was when I went to the high school. I was busy studying science. I was a good sportsman and playing the sports team. I was too busy. Eventually, I got sick, and doctor told me to stay home for 1 month. In that month, I really changed. That changed my life. I realized that we thought we are free and receiving good education, but we are really under captivity. It's a traditional value, judgment, cultural heritage, and everything bound me. And so I had a strong desire to become the master of myself and lead a meaningful life. And meaningful life for me is to, at that time, is to pursue a career of an outstanding scientist, not the famous. I just want to be an outstanding scientist and working together with idealistic people for an equitable and democratic world. And because before the war, during the war, it was really miserable. So when I entered university, I really had only 2 goals in my life. And I had a question at that time, and if I take all the courses offered in the Department of Chemistry and study well, am I going to be a good chemist? The answer is, of course, no. So I really become very independent in studying and with a group of people and learning from quantum mechanics, statistical mechanics, electricity, magnetism, and electronics. These are the things which was not taught in the chemistry department. So I had received a good education and did some research on the radioisotope in nature, and even did some X-ray diffraction for sandwich compound. Then I decided to go to the United States. I went to Berkeley. It's a wonderful place, beautiful campus. And that was the time. There's a student movement, a free speech movement, and turned into the anti-war movement. Students are criticizing the current government system and societal movement and changes. And I was really moved by the way students demonstrated and very orderly tried to express their view, and that the government understand what they are demonstrating. Actually, when I met all those people who attended the Berkeley from 1962-63, they all said that that's the best period of time for them to thinking about the future. For scientifically, I worked with Professor Mahan. He's an Irish American, really a very good teacher. The reason I say very good teacher was he didn't teach me anything. He always come to the lab and say, "What's new?" And I tell him what's new, what I was doing. The next question is, what are you going to do next? So I would tell him, what am I going to do next? He always nodded his head, sometimes make some comments, but after 2.5 years, he said, "Yuan, you can write up the thesis and finish it." I was furious at that time. I said, "Bruce, you didn't teach me anything, and just asked me 2 questions, and now you want to kick me out." Bruce said, "No, I'm not going to kick you out. If you want to stay, you can write up the thesis, you can be a postdoctoral fellow in my laboratory, and you can do whatever you want to do." Well, that's really exciting me. He said, "Oh, I can do whatever I wanted to do." So I said, "Bruce, I want to do ion molecule reaction under single collision condition. I want to trace the trajectory so I understand what's going on." He said, "Fine." So he left. He went to Oxford for sabbatical. He had lots of money in the Lawrence Berkeley Laboratory. So I learned to build a machine, and that was in a time, in 1965, there's no computer to help me designing anything and everything to do hand calculation, ion trajectories, and doing particle counting, also knowing the efficiency of detecting different ions. It's quite complicated. But that year, I learned a lot from engineers, scientists at the Lawrence Berkeley Laboratory, and that was in 1966. After spending a year, I built a machine, and it's working beautifully. Professor Mahan came back from Oxford. He was impressed that I built the machine in 1 year and did some experiment to show that the Hengeline did the measurement of momentum along the beam and said this is a spectroscopy mechanism. I did show that this is true. Bomb breaks and form N2H, and the angular velocity distribution is the consequence. So N2H scattered from the remaining hydrogen atom. And that year, Professor Hirschbach came through Berkeley. Actually, I wanted to do ion molecule reaction. It was partly because of him. He was doing alkyl scattering. Was quite successful. He came through and he said, "Yuan, that's the goal I've been having, to see the single collision events and measure angular and velocity distribution to visualize how chemical reaction takes place." So I went to Harvard. Dr. Hirschbach didn't have money. He borrowed the money from the Department of Chemistry, and I did find all over the world people are doing experiments on molecular beam try to see the individual molecular collision from angular velocity distribution, visualize how chemical reaction takes place, or even find the force field between atoms and molecules, and from there you can derive all the macroscopic phenomena. But I was amazed at that time. All over the world, people are doing experiment, and Dick Weinstein made a comment and said the reason molecular beam experiment was not working is because the sensitivity in the detection. He showed that the alkali metal, you can detect 100%. Ion, I did the experiment previous year, showed that every ion could be counted. But most of the molecule, you have to ionize it. Efficiency is only 1 part of 10,000, so experiment could not be done. I knew it's all wrong. It was all wrong. If you're in the big city, and a little child said, I want to see stars. I want to see stars. You cannot see stars in a big city with all the flood of light. So everybody was building the telescope, more insensitive telescopes to try to look at the star. That was not right. The way to look at the star is to tell the power company to turn off this light in the entire city, stop the automobile, then the little child can see the bright stars. And we spent about a year build the machine. Essentially, it's improving signal-to-noise ratio, not the detection efficiency. And that apparatus also works very well. That is the inside of the machine. So that was the first time we have been able to see collision between atoms and molecules and how the product distributed in a different quantum state and how the alignment of the initial molecule react and depend on the collision energy, how they change. Then we start to move into a more and more complicated system, look at the combustion processes, and that tradition of investigating atom-molecule reaction is really doing very well by Piero Casavecchia. He's sitting there in Perugia. Actually, when you look at the combustion processes, one cannot but to remind yourself, over the last 200 years or so, you see the Industrial Revolution, invention of the steam engine in electric motors, and as the science advances, material condition improves and people live better, live well, but then the consumption of fossil fuel increases, and those are the hydropower and nuclear power contributed a little bit, but most of the burning, most of the energy is coming from the fossil fuel. And if you also look at the population, last century, we started with 1.5 billion people. At the end of the century, it reached 6 billion, and now we are reaching 7.4 billion and heading for 9.7 by the mid-century. It means in a very short period, we mess up our environment. The sun is shining through the atmosphere, and we are living in very thin layers. And one thing we did see is the pollution. No matter where you go, you always face the problem of pollution that takes millions of lives away every year. But more importantly, what we are facing today is the global warming issue. Today, because of the increase in the greenhouse gases, Earth emits the photon in the infrared region, was absorbed by greenhouse gases, emitted down. On the other hand, sunshine emits the visible photons, go through the atmosphere, like carbon dioxide will not absorb visible photons. So there's an energy imbalance. The energy imbalance every day is equivalent to about 350,000 nuclear bombs, the size of the one who hit Hiroshima and Nagasaki, every day bombing the Earth. Temperatures rising. But scientists said we should not let it increase by more than 2 degrees centigrade. And IPCC every year, every 6 years, we will publish the current situations. And so, if you look at the global temperature rise and situation we are facing, it's really quite serious. Let us look at two things: extreme weather events, like typhoon or drought, extreme weather event, and also large-scale singular events. Something happened and suddenly bring the Earth to a different state. If you look at the temperature as a zero, this is the pre-industrial era, you see everything's white color. It means everything's okay. Then when color changes into orange, yellow, things become serious. And if you look at the scientists' suggestions that we should stop, let the temperature rise below 2 degrees. 2 degrees is already pretty bad. If you look at the extreme weather events, it's pretty bad already. And even the large-scale singular event is already turning into yellow and going to the red. This was not known 18 years ago. 18 years ago, it was not as bad. But from 7 years ago, scientists realized situation is really pretty bad. And if we do not do anything, temperature go up to 4.5 degrees, and everything is really miserable. Not only the extreme weather event, sudden change become very miserable. And actually now, temperature compared to the pre-industrial era already raised by 1.15 degrees. And we always said, not let it go to 2 degrees. 2 degrees is really miserable. That's why recently people said, preferably 1.5 degrees. Preferably 1.5 degrees. 1.5 degree is really, it's pretty bad already. So you look at the recent extreme weather event. There's a picture in Taiwan, one of the villages called Morakot. In one day, typhoon came, stayed, and dropped 1.7 meters of rain. 1.7 meters in one day. And village from the left turned into the village in the right, and entire village was swept down. And 600 people died overnight. And that's really a very green place, but precipitation is 1.7 meters per day. And then you look at the following year, typhoon hit Philippines. This typhoon, Yolanda, Haiyan, the wind speed was the record high and really devastated the entire island. 2015, politicians were awakened. 95 head of the state came to Paris and said we should reduce the carbon, decarbonization. And in 2015, in December, they came to a certain conclusion. One is global agreement, but this is a non-binding global agreement to move toward the 2 degrees centigrade limit, put in parentheses and said, and ideally to a 1.5 degrees centigrade limit. Because you all know 2 degrees is horrible. But the second thing, transferring $100 billion a year to help the developing country by 2020, that's not too hard, because this is only 0.1% of the global economic activities. 100 billion is really a small number. And the third thing is to revisit carbon reduction plans in 2020. But this year, it's interesting. Things change so much, and people are awakened. If 2015 is the year politicians are awakened, this is the year more people are awakened. One of the reasons is those extreme weather events are hitting many places. This is Houston. When Typhoon Harvey hit, really like nuclear bomb exploded. And the release of those energy is really very impressive. If you go to California. I used to live in California for more than 20 years. Forest fire always start in August, but this year start in June. And at that same time, Sweden was also forest fire was burning, and this is getting worse. Washington State was burning, Australia was burning because of the drought, extreme weather event. And if you try to go to Japan, Kansai Airport in Osaka was also devastated this year. All the typhoons hit toward Taiwan, all went to Japan. I have to tell Japanese that I didn't do it. I didn't do it. We just turn around and hit Japan. This is really bad. And that's the reason this year people seem to be awakened. And although when you look at those singular events, looks like, oh, it will happen once in a while. But if you look at this satellite picture often enough, this is the NASA satellite picture taken in August 23rd. You look at the entire Earth. The red color is really the black carbon image. See, many places are burning, wildfire smoke in California. You look at agriculture burning in Asia. So many places are burning. And you look at the light blue color, those are typhoons. Stir up the microparticle from the ocean. And the white part is the dust. So the entire Earth is really getting worse and worse. And we don't have much time to wait. But when I went back to Taiwan, I tried to help the industry, put enormous pressure to the government, said we need more water, we need more land, we need more electricity, we need more cheap labor, we need more talent, and put enormous pressure to the government. But we have to fight and said we also need to have a clean air and reduce the greenhouse gases. Well, I'm happy to say that last week, we finally convinced our government not to build the coal-fired power plant. Stop. It's not going to build it. But the entire world is moving the world toward natural resources, global cheap labor, and machine marches on. The free trade and globalization machine marches on and full speed ahead. And global GDP is increasing, produce lots of junk, pollution, and damage the environment. And what the young people say, we don't have much time left, really. I think scientists did the wrong thing by saying 2 degrees, 2 degrees. 2 degrees doesn't mean anything. You turn on the air conditioner, it's cool. But what's happening now is really extreme weather event. It caused the bubbling of methane from Siberia tundra or from methane hydrate from the ocean. This continuity will occur in relatively short time. IPCC said 10 years, we have 10 years left. We have to turn things around. This young lady is saying that they do something, you bunch of maniac, and maniac means me, together with many other people. My granddaughter was 12 years old. She always told her classmates, said, don't worry about global warming. My grandfather is working on this. He's very capable. He always gets things done. I said, no, we are making improvement, but we are losing the war at the current time. So this is something we really need to pay attention to. And politically, I said, if it's a global problem, we need to have global solutions. Individual country, rich country, might be able to do it to a certain extent, but many of the ones who will get hurt was the poor country. Socially, we must turn away from the path of the overdeveloped societies. When we say sustainable development, every poor country always thinks the development in a very luxurious way. We should turn away from that. Technologically, we must learn to store, transform, and share energy from the sun 10 years ago, scientists said electricity generated by sun will be as inexpensive as the electricity produced by fossil fuel. And we have accomplished that. It is true now, but we have not learned to transform it and store it more efficiently. Finally, I want to show a picture. The late Professor Yuan, he was my good friend. When he was working on the ozone problem, he did say, what's the use of having developed a science well enough to make predictions if, in the end, all we are willing to do is stand around and wait for them to come true? I certainly do not want to see the extreme weather event will bring us to a very uncomfortable state, and human survival will be in question. My time, my life is limited, but at the same time, I really have to worry about human society, what we are facing today. And I want to thank you again. I'm a chemist working in the laboratory, and after I became the president of Accademia Sinica, I become a scholar, a scientist, because I have to take care of humanity, social sciences, entire area of sciences. Then I became the president of International Council of Science, because I still have the idealism of wanting to work with the idealistic people to make this world a wonderful place to be. So my laboratory is now the entire Earth. I'm flying all over the world, and I don't have a good time clock. So previous lecture tried to tell me that you have to keep the good life schedule, but I can tell you that I have not been able to do it. In my pocket, there's a sleeping pill, because Ambien. For the last 10 years, whenever I need to sleep, I take Ambien to sleep, and life goes on. Well, thank you very much. But let's wait, fight together.